at the bottom of page 3, there is some more set terminology that we need to go through, okay? So the first thing that we have here is something called the universal set. So what a universal set is, it is symbolized by U. So if you see a set named U, the U is reserved for the universal set. It is a set that contains all of the elements being considered in a given discussion or problem, okay? So for example, you might encounter a problem later in this section where multiple sets are involved and there may be an overall universal set. And the universal set is going to contain all of the objects that are being considered in the problem, okay? And so if other sets are involved as well in the same problem, those sets will likely be smaller sets and all of their objects are also contained in the universe because the smaller sets have to come from the universal set where all objects are considered, okay? All right, the next thing we're going to talk about, and you may have seen this before, is a Venn diagram, okay? A Venn diagram is a diagram representing mathematical or logical sets pictorially as circles within an enclosing rectangle. Okay, the rectangle is going to represent the universal set, and common elements of the sets being represented by areas of overlap among the circles. Venn diagrams are useful in visualizing relationships between sets. Okay, so we're about to look at some examples of Venn diagrams, but the big thing that you need to remember right before you see this, so your Venn diagram is going to have a rectangle. Okay, so the rectangle is going to represent the universal set. So that's going to be everything under consideration in the problem that's going to be in the rectangle. And there may be smaller sets inside of the Venn diagram, and those will typically be circles, okay? So if you see circles overlapping, the areas of overlap, that is where the circles are going to have objects in common, okay? So again, the Venn diagram, it's very, very useful as far as visualizing relationships between sets. Okay, so we'll see some on the next page. So if you go to page 4, okay, right here you can see what a Venn diagram looks like, okay? We'll talk about this specific Venn diagram in just a second, but you see a rectangle and you see outside the rectangle, you see the letter U. That is just indicating that the rectangle is representing the universal set. Okay, so everything under consideration in the problem is inside the rectangle. There are two smaller sets within the rectangle. You have set A and you have set B, and they do overlap a little bit right where my clicker is. Okay, so they are going to have elements in common. You don't see any of the elements or the objects in the sets listed, okay? You can put them in there if you knew what they were. You could certainly put them on the Venn diagram, but just the fact that, you know, sets A and B overlap, they will have elements in common, okay? All right, so what we're going to do now on page 4, we are going to talk about 3 very common operations on sets. There's union, intersection, and complement, okay? So we're going to go through each one, talk about what it means, talk about it shading in a Venn diagram, and also look at the notation involved, okay? So the first one you're going to see here is union, okay? So if you take 2 sets, A and B, and you form their union, okay? So the union of sets A and B, this is the notation you're going to see, A union B. That is the set of elements formed by combining all of the elements of A and all of the elements of B into one set, okay? All right, so the best way you can think of a union, okay, because basically what you're doing is you're going to have 2 sets and you're joining all of their elements together to form a new set, okay? You can remember union by thinking of marriage. Marriage is a union. And so if you get married, then you and your spouse, you know, move in together and you're unioning or joining your households. Okay, so you're combining all of your things into one new home. Okay, so that's a way you can remember it. Okay, so again, union just means you're taking every object from set A and from set B, you're putting all of those things together to form a new set. Okay, all right, so if you look at the Venn diagram for a union, okay, so what you see here is you have your two sets A and B. Okay, there is some overlap here as shown in the Venn diagram. Okay, and you can see that the union itself is shaded in yellow. Okay, so I'll write that on here. So the union is shaded in yellow. Okay, so the union, the yellow part is A union B. Okay, that is everything in A. So this entire circle A is shaded in, and it's everything in B. Okay, so all of A is shaded, all of B is shaded. There, as far as the overlap is concerned, so if you have an object that's both in A and it's in B, it's also in the union. Okay, because think about, like, if you got married, if you had an item that your spouse happened to have as well, and now you have two of them, basically you would still, that item would still go to the new house when you moved in together. Okay, so if it's something shared between the two sets, it's still going to be part of the union. Okay. All right, so again, what I really need you to remember is what this symbol means, okay? So it's like a little U for union, okay? So if you see that symbol, it's one set unioned with another set, and you are just joining all of the objects in both sets to form a new set, okay? All right, so let's look at the next operation, okay? So intersection is next, okay? So intersection, the intersection of sets A and B, it is written as A intersect B. So this is the notation you're looking at for intersection. So it's like an upside down U. Okay. It is the set of elements common to both set A and set B. Okay. So if you look at the Venn diagram, you have your set A and your set B, and in yellow, the intersection is what's shaded. Okay. So the intersection, I cannot spell, the intersection, okay, I don't know. What am I doing here? All right, the intersection is the yellow shaded area here. Okay, so you can see this area of overlap. Okay, if I'm just going to draw a little star here. Okay, so think of the star as an object. That object lies within the A circle and it lies within the B circle, so that would be some common, that's an object that would be common to both A and B. And so that's what you're going to pull if you're looking for an intersection. You're looking for things you're looking for the objects that are common to both sets. Okay, a good way to remember intersection, okay? Think of a street, okay? So if you were, taking a walk somewhere and you somehow found yourself in the intersection of two streets, okay? If you were standing right smack dab in the intersection, then you're standing technically in both streets at the same time, okay? So you're standing in a place that's common to both streets. So that's a good way to think about it. Again, you've got to remember this symbol means intersection. Okay, do not confuse the two. You've got to know union is like the U, and then the intersection symbol is the upside down U. Okay, all right. Now, here's the thing. Okay, it is possible for two sets to have absolutely nothing in common. Okay, so if that were the case, the Venn diagram would not look like this because they actually, sets A and B would not overlap, okay? So the Venn diagram would actually look like what is right here, okay? So again, what's going on here, you still got your universe, and A and B are separate sets within that universe, but there's no overlap between the sets here, okay? That means that they have absolutely nothing in common. So this is what the Venn diagram would look like in that situation, okay? So what happens here, there's a special name for this, okay? The intersection is the empty set because there is, in this case, A and B have no common objects, okay? So if you're performing the intersection, it's the empty set because they have no objects in common, okay? So the special name for this is that A and B are disjoint sets, okay? So disjoint sets means that they're two sets that do not overlap. They have nothing in common. And so obviously that would change your Venn diagram. Okay, so again, if you do have two sets with objects in common in their Venn diagram, these two sets would overlap. And if they have nothing in common, then your Venn diagram would look like this, and they would be called disjoint sets. Okay. One more operation here. So far we've done union, we've done intersection. The last one at the top of page 5 is something called the complement. Okay. So here we go. It says the complement of a set A, symbolized by A prime, is the set of all elements in the universal set that are not in A. Okay, so the Venn diagram is very helpful as far as understanding what a complement is. So here you have your universe, that's the rectangle. Okay, so everything under consideration is inside the rectangle. And then you have the separate set A, okay, inside. Okay, so the yellow shaded area is a complement. Okay, so yellow shaded area is a complement. Okay, so what a complement is, it's everything in the universe excluding what is in A. Okay, so I'm gonna write that in here. Okay, so it is a complement is everything in the universe. So set U. You can call universal set universe, means the same thing. So a complement is everything in the universe excluding the objects in A. Okay, everything in the universe except for that set A. Okay, so this is what your Venn diagram would look like. Like I said, the yellow part is a complement because it's everything under consideration with the exception of the set A. Okay, you're looking at everything else. Okay, all right, so again, make sure you know the notation. Okay, the notation for complement, you're going to see that prime notation. Okay, so if you see a prime, that means a complement, and you would pick every object in the universe, but take out the ones that are in set A. Okay. All right. So what we're going to do now is we're going to move on to the next example, and we're going to look at sets of numbers, and we're going to do some practice with these ideas of union, intersection, and complement, as well as universal set.